Enterprises are burning real money on AI tokens, while the rest of us are chilling on subsidized plans. I'm sure you guys would have so far came across articles like Uber burned through its entire 2026 AI budget in 4 months, and now its CEO is questioning whether it's worth it. Similarly, Microsoft just told 100k engineers to cancel their Cloud Code licenses by end of June. And in recent events, Meta's Adam Mosseri says AI token budgets could soon be capped per engineer. So in this video, I want to break down how AI cost actually works and how to stop wasting money on it. And I say enterprises because enterprises are paying the actual API price per token, unlike the small startups and individual developers like us, who usually get to use the subscription, and those subscriptions are actually heavily subsidized. To give you an idea, look at this research conducted by Semi Analysis on Claude and OpenAPI subscription plans, where you could see that for just $20 per month, you can get a maximum of $400 of inference per month. And for $100, you can get $2,000 of inference per month. And for 200, it's $8,000 per month, which is approximately 40 times the ROI. Similarly, if you go for the OpenAI, you can get $14,000 of inference per month for just $200, which is literally 70x times the ROI, which is absurd. We are not sure how long they're going to keep this up, but while it is on, I highly recommend you guys to take advantage of these plans as much as possible. But in all, hopefully that makes it clear how awesome the deal is for people like us compared to enterprises who have spent real money through API pricing. But coming back to the topic, how do people in corporate teams or enterprises actually save AI costs? But before going to the saving tips part, I want to get everyone on the same page about how token pricing actually works. So if you take a look at the OpenAI's pricing page, the pricing is not just one simple number. You can have input tokens, cached input tokens, cache rights, output tokens, and in some cases different pricing depending on context or cache behavior. But the important part is the output. Like if you try to hover over the output column, you can see that output prices include visible output tokens and reasoning tokens, even though reasoning tokens are not visible via the API. So when you ask a model a question, you might think you only paid for your prompt and the final answer, but behind the scenes, the model may generate reasoning tokens, tool calls, read the tool results, and then use all of that as the context for the next step. To explain that better, take a look at this example. Say you hit the query like, who is smarter, Elon or Sam? So this query is sent to the LLM, and the LLM starts generating reasoning like, the user is asking me about a question, who is smarter between the two individuals, namely blah blah blah. And maybe in the reasoning, it ends up deciding that you should make a search tool call to actually learn more about these two entities or people. So after the tool call results, it ends up finding some facts like Elon has done XYZ, Sam has done XYZ, and then it finally ends up with an output like, according to XYZ research that it ends up doing, Elon is smarter. And then you end up doing another query and the same cycle repeats again. But here, if you see, you might think that the input is just the first query that you send to the LLM, which is just maybe a few words or tokens. But actually, it's much more than that. It's actually your query plus as well as the search results from the search tool, and it could be multiple tools, it could take multiple turns. So the actual input tokens could drastically vary from your actual input provided to the LLM. So these highlighted in pure white are actually the input tokens that's actually been provided to the LLM for inference. And all these grayed out things are the output tokens, not the exact output tokens. This is the actual output token which you are able to see. And this is what's called reasoning tokens, which providers like OpenAI doesn't actually expose to the users, but does contribute towards your AI expense. So now imagine a general scenario where your project manager asks you to use AI but keep the model cost low. Your natural instinct would be something like to go on OpenAI, search for model with the lowest pricing, and most probably you would end up with some model like Gemini, some model from the Gemini Flash series like Gemini 3.5. And honestly, that sounds correct. Cheap model, cheap will be ring, right? Right. Well, let's find out through some actual benchmarks instead of just taking my word. Well, here on the deep SWE leaderboard, I've selected the state-of-the-art models from OpenAI and Anthropic, where it shows the average cost per task plus compared to the accuracy. So the top right is the most efficient model. As we know that OpenAI and Claude models are drastically costlier than Gemini models, especially the Flash series. So if I enable the Gemini Flash 3.5, where do you think it would lie on this graph? Given if you believe the story of going by the model pricing pages, you would likely anticipate somewhere over this region, right? Like it should definitely be lower than these expensive model. But when I turn this on, it could actually end up costing you more than these seemingly so highly expensive models. And the reason again being, it actually ends up generating a lot more reasoning tokens, which accounts for the most of the effective pricing of the AI inference compared to the Anthropic and OpenAI models, especially the OpenAI models, which have drastically worked on or heavily worked on their efficiency since the 5.5 series. Because as you can see in the 5.4 and the 5.5, there is drastic difference between them, and apparently they figured something out and been able to get a lot more tasks done with higher accuracy on least token usage. This is where benchmarks like DeepSpeed become useful. Instead of only looking at token price, we can look at how much output a model generates per task and how many agent step it takes and how much quality it actually gives. So at the end, the real cost is not just price per token, the real cost is price per successful task. So now finally coming to the tips how we can make some real cost savings on our AI inference. Now that we know that the output and reasoning tokens are where a lot of costs can leak, the obvious question is how do we reduce them? Well, the answer is make it spit less token out. One very simple thing I can recommend is using this caveman skill. It sounds funny, but the idea is very practical. The skill makes the model communicate with very fewer tokens while keeping the same meaning, less fluff, less polite padding, less unnecessary explanation. And you might find it funny, but this is not just a meme. Like, if you take a look at some leaked reasoning style outputs people shared online, they look surprisingly similar. If you take a look at some of these snapshots, which shows the leaked API reasoning tokens from OpenAI, can see it says it goes like something like use core new modes, need info node 35 maybe should work, need add VAE encode for images, try full stop, and some more like we need solve integral, no need tools, combine, final concise, full stop. So this is actually legit. So I would highly recommend you use this. And if you decide not to use the exact caveman skill, take the learnings from it, build your own concise response mode, add it to your agents, make them stop writing S's when you only need decisions. The second tip is mainly for people using Claude Code CLI subscriptions. Everyone knows Claude has a reputation for the 5-hour limit getting exhausted very quickly when you actually try to get work done. It has improved recently, but compared to OpenAI style plans, it can still feel much tighter. So my approach is simply do not make Claude do every heavy lifting. So use models like Opus and Fable 5 to route heavier mechanical work to cheaper and more efficient models like GLM or OpenAI models, depending on what you have access to. So basically, keep Claude as the senior engineer or manager and let cheaper workers do the bulk of repetitive work, which can help you get more work done because of higher rate limits and reduce your costing because the models are cheaper. So now for the third tip, avoid extra high effort and ultra code modes as a default. I'm not saying never use them. If you have a massive code base migration or a genuinely complex multi-agent task, maybe it makes sense. But for normal everyday tasks, single file edits, quick questions, small bugs, or mid-run interactive tasks, ultra code can add latency and cost without adding quality. So for most work, just use Opus or Fable at high effort. This is usually the better default. And you can find many articles backing this point up, like for everyday work, ultra code adds latency and cost without adding meaningful quality improvement. So obvious reason to not to use that. And high effort on Opus is the right default. Now for the next trick, I have something interesting, which is instead of inputting as raw text, use images as input when it makes sense. Because text tokens and image tokens are calculated differently. So in some cases, sending dense context as an image can be cheaper than sending the image thing as raw text. Like there is actually a project PXPipe which does exactly that. And as you can see in this post by Ariel Mizrahi, which says like there is an open source project called PXPipe which implements or leverages this approach. The trick is in the pricing. Images are priced by pixel size, not by the number of characters embedded in them. So for workloads with massive prompts, this can cut costs dramatically. And for a special note, I would just like to highlight that it really depends on use case, but overall, Claude Fable 5 seems to have the most accuracy in image recognition compared to other models which have shown like 98 or 93 level of accuracy, but Fable has scored or got like 100% accuracy for image inputs. So yeah, just to keep in mind. Okay, so I think that covers all the points for AI cost saving from my side. One bonus point that I had was the Claude Fable 5 access on all paid plans has been extended through 19th of July. So if you haven't tried the model so far or were planning to use it, now's the time. Get it. It's an awesome model. Try to play around with it while you can because it would be migrated to API pricing after 19 July. So enjoy while you can. So yeah, those are the main tips I actually use to save real AI costs, understand token pricing, Do not trust pricing page blindly. Optimize output, reasoning tokens, use caveman style compression, use expensive models for judgment, cheaper models for heavy listing, avoid ultra code and extra high mode, and use image context where it makes sense. The goal is not to be cheap. The goal is to stop wasting money on confused loops. Hopefully, this helps you save genuine money on your AI usage. And this is my first YouTube video ever. So if this content genuinely help any of you guys save real cost in your company, hit the like or subscribe button, and at least definitely leave a comment below. Like leave any feedback on the audio, video, or content, anything. It would genuinely help. And thank you for watching. Until next time, peace.